A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
The faint point of light, first cataloged as 3I Atlas, has grown steadily brighter, its trajectory carrying it inward with a precision that has stunned astronomers and planetary scientists alike. Unlike the countless asteroids and comets that pass through the solar system on predictable loops, 3I Atlas is not bound by the sun's gravity. It is an interstellar traveler, a fragment from another system entirely, one that just happens to be sweeping past our neighborhood before disappearing into the galactic dark. The fact that new objects appear to be multiplying in its vicinity as it approaches Mars has electrified the global scientific community, reshaping ideas about what interstellar debris can do when it interacts with a planetary system. The story of its approach is not just one of orbital mechanics, but also of possibility, of questions that may redefine how humanity perceives its place in the galaxy. Before we start, smash the like and subscribe buttons for more updates. The first interstellar objects confirmed in modern history, 1I/ʻOumuamua in 2017 and 2I/Borisov in 2019, opened a door that could never again be closed. They proved beyond doubt that fragments from other star systems do occasionally wander through ours. But both events were fleeting, and neither was accompanied by anything resembling a swarm of secondary material. 3I Atlas has rewritten the rules simply by being different. Its path is not a sharp hyperbolic cut across the solar system, but a more gradual incline, one that allows extended observation. As it drifts nearer to Mars, the detection of faint, fast-moving companions around it has challenged even seasoned experts to revise models overnight. Are these fragments torn from the interstellar body itself? Or did it capture material during its long trek between stars? The multiplying objects are not mere curiosities. They may carry within them the chemistry of another world, and perhaps another story of planetary formation far from the sun. The timing of its approach to Mars has heightened the drama. Mars, already a focus of robotic exploration and the testing ground for future human missions, has suddenly become the stage for a cosmic encounter unlike any in recorded history. Orbiters circling the planet have adjusted their instruments to track the object and its companions, while ground-based telescopes on Earth and the Moon push to capture every photon reflected from its surface. The thin Martian atmosphere, coupled with the vantage points of rovers and landers, has added an unanticipated dimension to observation. If fragments of 3I Atlas skim the upper reaches of Mars's atmosphere, they may produce visible trails, a meteor storm not born of Martian skies but of interstellar passage. The multiplying objects have intensified speculation about the structural integrity of the primary body. It may be undergoing a process similar to cometary fragmentation, where volatiles heated by sunlight sublimate and tear away pieces of the core. Yet the behavior of the fragments seems less random than expected. Some appear to maintain coordinated paths, as though loosely bound to one another despite the negligible gravity between them. Such coherence raises questions about whether 3I Atlas originated not as a solitary wanderer, but as part of a larger structure, perhaps ejected wholesale from a system disrupted by gravitational chaos. Each new observation forces astronomers to wrestle with the possibility that interstellar objects may behave in ways no local analog has ever displayed. The implications stretch far beyond orbital calculations. Every fragment is a messenger from a distant stellar nursery, a shard that may carry isotopic ratios and chemical signatures unlike anything in the solar system. Spectroscopic data already hint at unusual compositions, with traces of complex carbon structures embedded in the dust halo surrounding the body. These are not conclusive proofs of biological precursors, but their mere presence reinvigorates the idea that interstellar wanderers could act as carriers of life's raw materials. If 3I Atlas and its companions deliver such matter into Mars's thin atmosphere, or even its soil, the red planet may temporarily host an experiment in panspermia played out under human observation. The notion that seeds of chemistry from another system might mingle with Martian dust is almost too vast to comprehend, yet entirely plausible under the unfolding circumstances. The engineering community has seized on the event with urgency. Missions already in place at Mars, such as Perseverance and Tianwen-1, were never designed for interstellar encounters, yet their instrument payloads offer unexpected potential. Plans are underway to adjust observation schedules, repoint cameras, and tune spectrometers to capture fleeting passes of the fragments. Meanwhile, new proposals are being drafted for rapid response missions, robotic couriers that could, in theory, intercept the trailing debris before it departs the solar system. While the logistics are formidable, launch windows, propulsion limitations, and communication delays, never before has humanity faced such a tangible opportunity to sample matter that formed under another sun. The cultural impact of 3I Atlas has spread as widely as its physical dust halo. The general public, already fascinated by Mars as the next frontier of human exploration, now watches as news outlets report on the approach of this cosmic visitor and its multiplying companions. Artists and storytellers are weaving its journey into narratives of cosmic kinship, while philosophers debate what it means for our sense of isolation. Each new update on the object's trajectory fuels speculation, some measured and scientific, others veering into the fantastical. Yet beneath all the noise lies the central fact. An emissary from another star system has chosen, by the impartial laws of physics, to sweep past the very planet humanity has dreamed of colonizing. The multiplying fragments present another profound implication. If interstellar objects regularly shed or trail companions, then the solar system may be strewn with unnoticed debris from countless passers-by. This challenges the perception of interstellar visitors as singular and rare. Instead, it hints at an ongoing flux, a quiet rain of material across galactic neighborhoods. Detecting 3I, Atlas's companions, may be less about extraordinary circumstances and more about improved technology finally catching what has always been there. Such a realization would recalibrate estimates of how much interstellar matter actually interacts with the solar system over millions of years, and by extension, how much it may have influenced the early chemistry of Earth itself. The approach to Mars offers a natural laboratory for testing these ideas. As the fragments draw nearer, planetary protection specialists express both excitement and caution. The thought of foreign organic compounds mingling with Martian regolith sparks visions of discovery, but it also raises questions about contamination and the integrity of ongoing life detection experiments on Mars. If material from 3I Atlas settles on the planet's surface, future missions could misinterpret its alien chemistry as evidence of indigenous Martian life. Disentangling such signals will require painstaking analysis, yet the potential reward, studying interstellar chemistry preserved in situ, is unparalleled. From a broader cosmic perspective, the event underscores the dynamism of galactic ecosystems. Stars form, evolve, and die, scattering their remnants into interstellar space. Planetary systems collide or destabilize, hurling asteroids and comets outward into trajectories that wander for eons. That one such fragment now intersects Mars is a reminder that the solar system is not an isolated stage, but part of a vast interplay of celestial migration. For every 3I Atlas detected, countless others pass unseen. Each carries the story of its origin, a story written in mineral lattices and isotopic fingerprints, awaiting only the instruments capable of reading them. The sheer spectacle of the event cannot be overstated. As Mars rises in the night sky, telescopes track not just the crimson planet, but the faint shimmer of interstellar companions racing beside it. Astronomers speak of the poetic alignment, a world that has captivated human imagination for centuries now, welcoming travelers from another star. For many, this convergence feels less like coincidence and more like a call to expand both scientific and human horizons. It is not only a Martian encounter, but a galactic conversation, one in which humanity has a front row seat. At the heart of the excitement is the unknown. The multiplying fragments may vanish into the void without leaving more than data streams and images. Or they may provide the first tangible samples of alien planetary chemistry within reach of our instruments. They may confirm theories about panspermia or dissolve them entirely. They may alter the trajectory of planetary exploration, prompting new missions designed not just for Mars, but for the interception of interstellar wanderers. The only certainty is that nothing will ever again be quite the same after 3I Atlas has swept past Mars. What makes this moment especially potent is that it represents the meeting of two frontiers. Mars has always been the near frontier, the reachable next step for human explorers, while interstellar space has remained the far frontier, distant and untouchable. With 3I Atlas approaching Mars, these two domains converge. The near frontier and the far frontier briefly touch, offering a bridge of possibility that spans the gulf between planets and stars. For scientists, dreamers, and explorers alike, it is an encounter that crystallizes why humanity looks outward at all. To glimpse the unfamiliar, to understand the greater whole, and to find connection in the vast expanse. The multiplying objects trailing 3I Atlas remind us that even the smallest fragments can shift perception. Each speck of dust carries with it the potential to answer questions about origins, about the universality of chemistry, and about the interconnectedness of worlds. Mars, with its silent deserts and whispering winds, now prepares to play host to a drama written in starlight and distance. Humanity watches, instruments tuned, imaginations alight, as the interstellar visitor and its companions draw near. In this moment, the cosmos feels not empty but full, alive with motion, and bound together by encounters that defy expectation. The unfolding journey of 3I Atlas toward Mars, accompanied by the mysterious multiplication of new objects in its path, has become one of the most riveting spectacles of modern astronomy. Each day that passes brings additional discoveries, sharper images, and more refined models, all of which expand the magnitude of the event. What makes this phenomenon extraordinary is not only the fact that humanity is witnessing the third confirmed interstellar object to enter the solar system, but also the dynamic, almost theatrical way in which it announces itself, splitting, shedding, or generating companions like celestial breadcrumbs along its trajectory. No single analogy can capture the breadth of implications, but the unfolding narrative demands exploration from multiple angles: scientific, philosophical, technological, and even existential. The idea that Mars is now the stage for such an encounter is particularly striking. For centuries, the red planet has been the focus of mythology and scientific curiosity. From ancient civilizations mapping its blood-red glow across the night sky to modern agencies sending rovers and orbiters to examine its surface, Mars has served as a symbol of exploration and aspiration. Now it has become the backdrop for a visitor not of this solar system, but of another star altogether. This convergence of themes, the human drive to explore Mars and the cosmic gift of an interstellar traveler, creates a once-in-a-lifetime synthesis of meaning. It is as though two separate narratives, the local and the galactic, have suddenly collided. One aspect that has fueled excitement is the unpredictability of the multiplying fragments. Early observations suggested perhaps one or two companion objects trailing in its wake. Within weeks, that number ballooned as detection instruments revealed a scattering of debris, some larger than boulders, others no more than specks of dust reflecting faint glimmers of sunlight. Their motion is far from random. They stream together in patterns that suggest underlying forces at work, though not in ways that conform to known physics of comet fragmentation. This has prompted bold theories. Could the fragments represent remnants of a once cohesive structure, perhaps a disrupted binary asteroid from another system? Or might they be shedding in response to solar radiation in ways that challenge current models of material strength under interstellar conditions? Spectroscopy has intensified the mystery rather than resolved it. Preliminary data indicate highly unusual mineral signatures with silicate patterns that diverge from common solar system asteroids and volatile traces that seem resistant to solar heating. Some of the fragments show strong spectral bands associated with complex carbon molecules, structures that on Earth are linked with the building blocks of life. Though no scientist has claimed evidence of biology, the tantalizing possibility of encountering material pre-assembled under alien conditions has stirred excitement across disciplines. Each fragment, in essence, is a sample jar delivered from another sun, one that might hold the secrets of how chemistry differs in star systems with other elemental distributions and histories. Mars, with its thin atmosphere and active scientific presence, provides a unique vantage point for observing these fragments up close. Unlike Earth, whose thick protective shield would vaporize much of the incoming material before it reached the ground, Mars offers the possibility of interstellar particles penetrating deeper into its atmosphere, or even settling on its surface. This raises extraordinary opportunities. Instruments aboard rovers such as Perseverance, though designed primarily to study Martian geology, could serendipitously capture traces of alien dust. Orbiters might record the ionization trails left by fragmentary meteors as they skim the atmosphere. Even the soil on Mars's plains could, within days or weeks, contain a sprinkling of matter from another star system. Material that humanity might one day scoop up, analyze, and compare against terrestrial chemistry. The timing of this encounter is fortuitous in another sense. Space agencies around the world have already been considering the feasibility of sample return missions from Mars. With 3I Atlas approaching, the prospect of returning samples from Mars that contain interstellar material becomes tantalizingly real. This was never part of mission design, but it could become one of the greatest windfalls in the history of exploration. Imagine retrieving to Earth not only Martian soil, but also microscopic fragments of rock and dust that began their journey around another sun. The chance to hold such material in laboratories would revolutionize planetary science, astrophysics, and even philosophy. For the first time, humanity would be in direct physical contact with an alien system, not through telescopes or theory, but through tangible matter. The social dimension of 3I Atlas's approach cannot be overlooked. In classrooms, the story has reignited interest in astronomy at a level reminiscent of the Apollo era. Teachers describe students peppering them with questions about interstellar objects, galaxies, and the chemistry of stars. Museums and planetariums report record attendance as the public seeks to understand the visitor's significance. News broadcasts cover its journey like a sporting event, charting its progress across the inner solar system. The multiplying fragments, with their shifting configurations, have been likened to a dance in space, a choreography that reminds humanity of the dynamic, interconnected nature of the universe. For once, a cosmic event has captured global attention not through fear of collision or destruction, but through awe and possibility. Governments, too, have begun to take notice. The implications of interstellar matter brushing past Mars are not merely scientific. They also touch on questions of strategy and leadership. Spacefaring nations realize that whoever successfully studies or retrieves interstellar fragments will shape the next era of scientific discovery. Cooperative initiatives are forming, yet underlying them is a quiet competition reminiscent of earlier space races. Proposals for new missions, fast probes capable of redirecting toward the fragments, are being drafted at unprecedented speed. Though the technical challenges remain immense, the incentive is irresistible. The chance to claim humanity's first direct encounter with alien planetary material. Amidst the fervor, philosophers and cultural commentators have stepped forward to interpret the larger meaning of the event. Many see 3I Atlas and its companions as symbols of cosmic interconnectedness. Reminders that the solar system is not a self-contained bubble, but a participant in the broader galactic flow. The multiplying fragments are viewed as emissaries, shards of distant stories written into the fabric of the universe. In some circles, they have even been imbued with spiritual significance, portrayed as messengers, or signs of humanity's readiness to take its next step outward. While such interpretations diverge from the rigor of science, they testify to the profound impact that cosmic events can have on the human imagination. One of the most intriguing scientific debates centers on the mechanics of the fragmentation itself. If the multiplying objects are indeed breaking away from the parent body, the process appears far more orderly than known cases within the solar system. Cometary fragmentation usually produces chaotic scatterings of material, driven by uneven heating and internal pressure. 3I Atlas, however, seems to be shedding in cascades that retain coherent paths. This has led some to speculate that its structure might include unusual internal layering or tensile properties unlike anything in solar system rocks. Others propose that electromagnetic interactions, perhaps linked to the solar wind, are guiding the fragments in ways not yet understood. Whatever the explanation, the event forces a rethinking of assumptions about how matter behaves when formed under alien conditions. The potential for capturing fragments is not purely hypothetical. Even now, Earth's upper atmosphere may intercept a dusting of microscopic grains dislodged from 3I Atlas's halo. Specialized detectors aboard satellites could, with luck, register their presence. These grains would be invaluable because they would represent unaltered interstellar material arriving intact at Earth. The challenge lies in distinguishing them from the constant rain of local meteoric dust. Yet, advances in isotope analysis, capable of identifying fingerprints unique to alien chemistry, could eventually confirm their origin. Should such confirmation arrive, it would mark the first verified sample of interstellar matter ever studied on Earth, obtained not by spacecraft interception but by the planet's own passive collection. At Mars, the event has implications beyond pure science. The thin atmosphere is already known to host peculiar seasonal variations in methane, puzzling scientists for years. If interstellar fragments interact with this atmosphere, they may influence its chemical balance in unexpected ways. Monitoring these interactions could provide new insights into both Martian atmospheric dynamics and the chemical behavior of alien matter. Furthermore, the possibility that interstellar dust may mingle with the ice caps or become embedded in regolith layers raises fascinating scenarios for future excavation. Mars could, in effect, become a natural archive of interstellar debris, storing fragments in its geology for future explorers to uncover. As 3I Atlas continues its approach, it has also sparked new questions about detection and preparedness. If interstellar objects regularly carry multiplying companions, how many have passed unnoticed in the past? What instruments must be developed to detect them earlier, perhaps even before they enter the inner solar system? The lesson of this encounter is clear. The cosmos is more crowded and dynamic than once assumed. Humanity must build the capacity not only to observe such events, but to respond to them through rapid missions, sample retrieval technologies, and flexible scientific infrastructure. The multiplying fragments serve as both opportunity and challenge, urging humanity to upgrade its role as a galactic observer into that of an active participant. Beyond the technical and scientific, there is the emotional resonance of the encounter. People across the globe, looking at Mars through telescopes or simply following news updates, feel a renewed sense of connection to the universe. The multiplying objects, though distant and silent, evoke feelings of kinship, as if the cosmos is not indifferent but instead rich with encounters waiting to unfold. In an age often dominated by terrestrial conflict and division, the shared wonder of 3I Atlas reminds humanity of its collective place under the stars. It invites people to dream together, to imagine futures where interstellar matter is not just studied but visited, where humanity itself may one day travel outward as these fragments have done. As the days shorten to weeks before closest approach, anticipation builds like the overture to a grand cosmic symphony. Astronomers fine-tune their instruments, engineers brainstorm mission adaptations, and philosophers sharpen their arguments. The multiplying fragments continue to proliferate, each one a question mark racing through the void. Mars, silent and ancient, waits beneath their path. The encounter is not yet complete, and its full significance remains just beyond reach. Yet already the story of 3I Atlas has expanded the boundaries of thought, inviting humanity to see the galaxy not as distant abstraction, but as an active presence brushing against the shores of its nearest frontier. The nearer 3I Atlas draws to Mars, the sharper the contours of its mystery become. The multiplying fragments, once faint smudges at the limits of detection, now appear as distinct entities, moving with strange consistency around the main body. What was initially described as a trail of debris is increasingly being understood as a more organized formation, an arrangement that challenges long-held assumptions about how material behaves in interstellar transit. The fragments shift position relative to one another, sometimes drawing closer, sometimes spreading apart, as though choreographed by forces beyond simple gravity or solar radiation. The solar system, long thought to be a stage for predictable planetary motions, suddenly feels more alive, threaded with unexpected dynamics that hint at the complexity of the galaxy beyond. For planetary scientists, this encounter has become a natural experiment in how foreign material interacts with local conditions. Mars is not only an ideal vantage point for observation, it also provides an arena where fragments of 3I Atlas may leave observable imprints. The possibility that dust and microparticles will skim across the Martian atmosphere has triggered excitement across research centers worldwide. Such encounters could alter the planet's tenuous climate, even if only briefly, introducing exotic molecules into circulation. Instruments already monitoring Martian weather patterns may detect anomalies in temperature gradients, albedo, or chemical composition during the object's passage. If such anomalies are traced directly to interstellar material, it would mark the first time scientists could correlate planetary atmospheric changes to the influence of a wandering alien object. Astrobiology has found a new foothold in the debate surrounding 3I Atlas. For decades, the question of whether life could spread between star systems through natural carriers has hovered on the fringe of scientific speculation. Now, with fragments streaming through the inner solar system, the concept of panspermia is experiencing a revival. If complex organic molecules survive the interstellar void and withstand the harsh environment of solar approach, they may indeed serve as seeds scattered across galactic neighborhoods. Mars, with its history of water and its potential for subsurface ice, becomes an intriguing testbed. Should interstellar fragments land intact on the Martian surface, they could intermingle with local chemistry in ways that blur the line between planetary and cosmic evolution. Whether or not life arises from such mingling, the possibility that ingredients for biology are shared across stars deepens the sense of connection among worlds. Technological innovation is already being spurred by the challenge of studying 3I Atlas. Traditional telescopic observation has its limits, especially as the fragments grow fainter against the backdrop of Mars's glare. To overcome this, engineers have deployed adaptive imaging techniques, stacking thousands of exposures to sharpen details that would otherwise be lost. Space-based platforms are coordinating observations in near real time, sharing data streams across continents to build composite models of the fragment's motion. The event has accelerated the integration of artificial intelligence into astronomy, with machine learning algorithms combing through petabytes of data to detect subtle patterns and anomalies. These tools are not only vital for understanding the current encounter, but will also become the backbone of future efforts to monitor and intercept interstellar objects. The sheer strangeness of the fragment's behavior has also rekindled speculative discussions in scientific circles. While most researchers remain cautious, the idea that some interstellar objects might display quasi-artificial qualities has crept into conversations. Could the coherence of the fragments indicate structural properties engineered rather than naturally formed? This remains an extreme hypothesis, with little direct evidence. Yet the persistence of the question illustrates the depth of the puzzle. Even without invoking artificiality, the fragments challenge fundamental assumptions about how material binds and breaks apart under interstellar conditions. Whatever the explanation, the encounter forces humanity to expand its imagination about what forms matter may take when forged under alien skies. Meanwhile, the human imagination has raced ahead. Writers, filmmakers, and artists are weaving the story of 3I Atlas into visions of interstellar contact, cosmic migrations, and the fragile beauty of planetary alignment. Galleries mount exhibitions of imagined vistas where Mars glows beneath a sky streaked with alien meteors. Novelists imagine civilizations whose debris drifts across galaxies, their histories written in the fragments of shattered worlds. While these cultural responses do not alter the science, they enrich the event with meaning, ensuring that its impact will resonate long after the fragments vanish into the outer darkness. Politically, the encounter has underscored the need for international cooperation in space. No single nation can hope to capture the full breadth of data or deploy rapid missions alone. The complexity of observing, analyzing, and potentially sampling interstellar fragments requires pooling resources and expertise. Already, multinational working groups are forming, drafting agreements on data sharing and mission planning. Yet alongside cooperation lurks quiet rivalry. The prospect of returning interstellar material carries immense prestige, and spacefaring powers are keenly aware of the symbolic and practical advantages of being the first to analyze alien chemistry in Earth's laboratories. This delicate balance of collaboration and competition may well define the next phase of space exploration. The educational ripple effect is immense. Young students who might once have looked at the night sky with passive wonder now follow updates about 3I Atlas with enthusiasm. Amateur astronomers contribute observations, some of which have proven valuable in refining orbital models of the fragments. Online forums buzz with speculation and data sharing, turning the event into a participatory experience that bridges professional science and public engagement. In this way, 3i Atlas is not only expanding knowledge, but also expanding the community of those who care about and contribute to that knowledge. As the fragments approach closer to Mars, another layer of inquiry has opened: their potential to collide with the Martian surface. While most fragments are expected to disintegrate in the atmosphere or skim past harmlessly, the possibility of impacts cannot be dismissed. Such collisions would provide a natural experiment, delivering interstellar material directly into Martian soil. Rovers or landers fortunate enough to be near impact sites could one day sample these deposits, preserving within their instruments a story that began light years away. The notion that Mars, so often viewed as a dry, barren desert, may become a repository for alien matter adds an almost poetic layer to its already mythic role in human culture. From a long-term perspective, the 3i Atlas event is a reminder of the dynamic permeability of the solar system. It is not a sealed bubble, but a porous crossroads, intersected by travelers from other stars. This recognition carries profound implications for planetary defense as well as scientific exploration. While 3i Atlas poses no threat of collision with Earth, its approach highlights the unpredictability of interstellar visitors. Some may arrive on more hazardous trajectories, and the ability to detect and respond will become increasingly essential. Thus, the encounter serves as both inspiration and warning, urging humanity to refine its vigilance as it steps deeper into the galactic conversation. Even more subtle are the philosophical ripples. The multiplying fragments invite contemplation of time on scales far beyond human lifespans. Each piece has traveled for millions, perhaps billions of years across the void, only to appear now, coinciding with humanity's ability to observe it. Such convergence prompts questions about the nature of coincidence and meaning in a universe governed by physical laws. Some see in it a reminder of humanity's fleeting place in cosmic history. Others interpret it as affirmation that humanity's emergence as a technological species is timed to coincide with encounters that broaden awareness. Whatever the interpretation, the event forces a reckoning with the immensity of scale that underlies existence. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3i Atlas multiplying objects as it nears Mars? We want to hear from you. Thank you for watching and see you next time.